Okay, you ready? Let's go through this. I have 4 examples and then we're done. So while the tornado's raging outside, we can do math inside. It's like, a white Christmas.
So do we lock the doors so people can't get in if there's a real tornado?
Yeah, we lock the doors, keep all the hoodlums outside so that we can concentrate on our nice, quiet math. Okay, so what we're working with is still solving. I just did these so that we're just doing general solutions on all of them. Okay, so we're going to focus on factoring and squaring. Factoring. So we have 2 trig functions with this. The problem is, even though I have 2 trig functions with this, if I would take the cosine and I would change it using Pythagorean, that would change it into a sine. So that still would not help me get rid of anything. If I would start trying to simplify, it would just make it into a bigger mess. Because if I simplified, the cosines would not cancel out because cosine is on the top of cotangent. So that would just turn it into cosine cubed. And I would still have sine on the bottom. Okay, the easiest way to take care of this is notice that there's a cotangent in both of these. So the easiest way is just to factor that out. Because whenever we have factors, what can I do to each of those factors now? Equal them to 0. So now I do have my trig functions separated. So that's one way of splitting up my trig functions and getting them by themselves without having to go through all that hassle of simplifying. It's just by factoring them and separating them by setting each factor equal to 0. Okay, so let's see. On my unit circle, which I lost, when does cotangent equal 0? Remember, cotangent is cosine over sine. So I'm looking for whenever cosine is equal to 0. So cosine is the x values. So that'd be pi over 2 and 3 pi over 2. Okay, over here, I get cosine squared of x equals 2. So cosine of x equals plus or minus square root of 2. This one, I'm going to tell you this one has no solution. Why? Okay, well, it doesn't have to actually be on the unit circle. Because if it's not on the unit circle, I could actually use the inverse cosine and figure it out. What does square root of 2 equal? Okay, what do you know about cosine? What's the largest cosine value?
1.
1. What's the smallest?
0.
Negative 1. Okay, so is it possible for cosine to equal square root of 2? No. We've already done so. Yes, this is our shelter.
Who would want to go? People come in here. So if we died?
If we die underneath all this concrete, it's meant to be. Literally, we're surrounded by concrete. So
I know that somehow fails if there's a defect.
if a tornado knocks this much concrete down, it's meant to be.
You're suing him? You're gonna be dead. How are you gonna sue him? If I die, I'm gonna sue you.
If I'm dead, you can sue me.
My estate will sue your estate.
Yeah, good luck with that. You can get my PS4. If I'm dead. Okay.
You guys are witnesses. I just want you to know that.
You better sleep with one eye open.
With these, you can factor this just like a normal thing. So just like I had this. So I just factor that like normal. So I would start by finding two numbers that multiply to -2 and add to -1. So you're going to get plenty of practice with your factoring again. So let's see, that's going to be -2 and +1. I usually like factoring it with the x's because it takes less writing than writing down sine over and over again. That's the only reason I'm over here doing it like this. So that's what that factors into, which means over here, this factors into 2 sine x plus 1 sine x minus 1. Huh?
It's okay if we do that like on the text.
Yeah, I don't care. I mean, honestly, I'm starting with your answers, then looking back at your work. But yeah, I mean, what this is doing is this is substituting x in for sine of x and doing the work, and then replacing the x back with sine of x. That's very common practice in math, is to use that substitution. Wherever you get to calculus, a lot of times you use u and you substitute u in for stuff in calculus to do integrals. Okay, so I just finish off my problem like normal. By setting each factor equal to 0. So over here, I want to know when sine equals -1/2. And over here, I want to know when sine equals 1. And I'm just going to put them all in one big grouping. So let's see, sine equals -1/2. So I'm looking at my y values. So let's see, equals -1/2 at 7 pi over 6. 11 pi over 6, and it equals 1 at pi over 2. So pi over 2.
Wait, so if they both work, they're all one thing?
Yeah, there's no, I mean, I could put them in separate things or I can put them all in one thing. Doesn't matter. I'm just writing down my answers. And it's just like whenever you solve for x, you know, whenever you're solving for x, you get like x equals 3 and x equals 2, or you could write it as x equals 3 and 2. Doesn't matter as long as you say what x equals. What was it I used to be able to do?
Can you do a dog?
What is that? Ew. It's not funny at all. It's a weird. It's like a mutant dog, bro.
I can see the dog with that.
What is that?
It's like a frog.
It's like an ostrich.
Yeah.
Is this supposed to be an ostrich? I'm pretty sure it's supposed to be an ostrich.
Alright, everyone. I'm gonna broadcast.
It's weird to say that.
Wait, I didn't know who that is.
Don't be jealous.
A nice
Puppy. Why are we
10.
learning math in here? We need to learn how to do that.
This it teaches.
Oh, I gotta do it the other way. Dang it! Oh! Okay. Okay, now whenever this ends up being 2 videos, you know why. Okay. This one has 2 trig functions, so I just want to do one real quick like this. What do I need to do in order to solve this?
You subtract +3.
Nope.
You substitute times squared x.
With
That Pythagorean.
Pythagorean.
Cosines. Well, negative
So I need to change this into cosine because there's no way to get rid of this cosine. So I need to change sine into cosine. Yep. All right, and just because I hate factoring with a negative at the front, I'm going to multiply everything by -1. Oops. Helps if I multiply everything by -1. All right, so 2 numbers that multiply to 2 and add to -3 would be -2 and -1. Okay, so I group and factor, so I can take a 2 cosine x out of this one, which should leave me cosine x. See, this is what I didn't want to do. This is why I take off to the side and factor over there. Okay, so I factored it now. So I set each factor equal to 0. See, the tornado drill doesn't look so bad now, does it? Okay, in places where cosine of x equals 1/2, pi over 3, and where? Not 2 pi over 3. 5 pi over 3. Uh-huh. Pi over 3, this would be negative because it's negative x values. So the other place would be down here at 5 pi over 3. And cosine equals 1 at 0. Okay, last one has a problem with it.
What's that
Oh,
problem?
part of it is the same problem as the previous one. It has two trig functions. Now, I could change sine into cosine again using Pythagorean, except for the fact in order to use Pythagorean, I have to have squares. Do I have any squares? No.
So can you square the whole thing though?
Yep. So if you don't have squares, create them. So if I don't have them and I want them, I can create them. Now, this does create an issue. Whenever you square a problem, you have a tendency to create solutions that aren't real. So that means we have to check our solutions at the end. Okay, so cosine squared of x plus 2 cosine of x plus 1 equals sine squared of x. So now we can change it. I can change either cosine squared or sine squared, but I'm going to want to change the sine squared because of this cosine. I can't change that cosine. So since I'm stuck with this one, I'm going to want to change everything into cosines. So use Pythagorean and change that over. Because I can't use Pythagorean if things are not squared. Okay, move everything off to the left. Things start working really nicely for me because my 1's disappear. I can divide off the 2's. So that makes my factoring really nice and easy. So I have cosine of x equals 0. And I don't know what I was writing there. Okay, so cosine of x equals 0 at... What am I thinking? Oh, pi over 2 and 3 pi over 2. And equals 1 at, or sorry, negative 1. I should actually solve that out, sorry. At pi. Huh? Yeah. Okay, now, since I squared it, I have to double check my answers. Because they're not all going to work. I created answers that are not real. Alright, so I have to go back to my original equation. I need to plug these in. So if I plug in pi over 2, so let's see, pi over 2 would be 0 plus 1 equals 1. So that one checks. So pi over 2 is good. So let me start making a list down here. Okay, so let's try 3 pi over 2. Okay, that's 0 plus 1 equals negative 1. That one does not check, so that is not a solution. Okay, and let's try pi. Okay, so that's negative 1 plus 1 equals 0. That one checks. So this time I only created one false solution. Sometimes there'll be more. But you always have to do that whenever you do that squaring thing.
You gotta start talking.
Whenever you take sine squared plus cosine squared, it equals 1. Yeah.
Yeah, I was distracted like the entire time. I know.
I could always teach with my goggles on too.
I can totally read it. And just like read it.
I could teach with my what is it? My inbred face. That's right, Pete. Does this help you with your reading?
How about you make a note saying that this is the real problem? No, I'm waiting for someone else to like look at these notes and just like, what the hell?
Oh, am I still recording? I am.